September 1st, 1859, the hour before dawn. Telegraph operator Frederick Royce sits alone in his Boston office watching his instruments with growing unease. For 2 nights, the sky has been burning. Curtains of crimson and green light cascade across the heavens where no aurora should ever reach. Something unprecedented is happening. Suddenly, his telegraph machine erupts. Sparks shower from the instrument. The paper catches fire. Royce leaps back as flames consume his desk. From Portland to Washington, from London to Paris, the same nightmare unfolds. Telegraph operators scream as their equipment explodes. Some are thrown across rooms by electric shocks. In Cuba, people pour into the streets, staring upward in terror. The aurora borealis, never before seen this far south, paints the tropical night in colors that shouldn't exist. Ship captains worldwide report their compasses spinning wildly, needles jerking in circles, pointing nowhere and everywhere at once. Navigation has become impossible. At the Kew Observatory near London, scientists watch in astonishment as their magnetometers go completely off scale. The readings are physically impossible, yet they're real. Then something even stranger occurs. In Boston, Royce disconnects his battery pack entirely. No power source remains. Yet when he touches his telegraph key, it still works. Across the Atlantic, operators discover they can communicate solely on the aurora's power. Messages flow through the wires powered by the storm itself. The Earth has become a battery. This is the Carrington Event, the most powerful geomagnetic storm in recorded history. And it all began 93 million miles away, with one man looking at the sun. September 1st, 1859. The world hummed with a new kind of energy. Telegraph wires stretched across continents like artificial veins, carrying the pulse of human ambition. In London, merchants tracked shipping prices. In New York, newsrooms buzzed with stories from distant lands. Humanity had conquered distance itself, or so it seemed. But 93 million miles away, something ancient stirred. The sun, that faithful companion that had nurtured life for billions of years, was about to remind us how small we truly were. Richard Carrington was not a man given to fantasy. A respected British astronomer, he had spent years documenting sunspots with meticulous precision. September 1st dawned clear over his private observatory in Red Hill, Surrey. The morning light filtered through the telescope dome as Carrington prepared for another routine day of solar observation. He carefully projected the sun's image onto a white screen, a technique that protected his eyes while allowing detailed study. The sunspot groups he'd been tracking were growing larger, unusually larger. By September 1st, the largest group of sunspots Carrington had ever recorded sprawled across the sun's face like dark continents on a burning ocean. Across the Atlantic, American astronomers made the same observations. The sun was more active than anyone had seen in living memory. Nature was loading a weapon aimed directly at Earth. In telegraph offices from Boston to Bombay, operators went about their daily work, unaware that the wires they touched would soon become conduits for forces beyond human comprehension. The technology was barely 2 decades old, yet it had already transformed civilization. Messages that once took months to deliver now arrived in minutes. Progress seemed unstoppable. But our electromagnetic infrastructure, so proudly erected, had created an unintended vulnerability. We had wired ourselves into a vast antenna, perfectly tuned to receive what the sun was about to unleash. As September 1st turned to night, the sun set on a world balanced on the edge of transformation. In the darkness, no one could see the magnetic storm gathering in the void between worlds. September 1st, 1859. The morning sun rises over Red Hill, Surrey, where amateur astronomer Richard Carrington climbs the stairs to his private observatory, unaware he's about to witness something no human has ever recorded. At precisely 11:18 a.m., Carrington adjusts his brass telescope, projecting the sun's image onto a white screen. He's meticulously sketching sunspots, dark blemishes on our star's surface, as he does every clear day. Then, without warning, 2 intensely bright spots erupt on the sun's surface. Carrington freezes. In 20 years of solar observation, he's never seen anything like this. The spots are so brilliant, they're visible against the sun itself. His heart racing, Carrington sprints to find a witness. These luminous kidney-shaped spots are moving, changing, pulsating with an otherworldly energy. He must confirm he's not hallucinating. He returns breathless, but finds no one to verify what he's seeing. Alone, he watches in awe as the bright spots dance across the sun's face for 5 full minutes before vanishing as mysteriously as they appeared. Carrington doesn't know it yet, but he's just witnessed the largest solar flare in recorded history. A massive coronal mass ejection, billions of tons of plasma, is now hurtling toward Earth at 4 million miles per hour. 17 hours. That's all the time humanity has before this electromagnetic tsunami reaches our planet. In 1859, no one understands what's coming. No one can predict the chaos about to unfold. Meanwhile, at Kew Observatory in London, another observer witnesses the impossible. The magnetometers, instruments measuring Earth's magnetic field, suddenly swing wildly off their scales, as if the planet's invisible shield is being battered by an unseen force. What Carrington has witnessed is a solar superstorm, a perfect storm of cosmic proportions. The sun has hurled a weapon at Earth, and in less than a day, the modern world will burn. September 1st, 1859, 11:18 a.m. While Richard Carrington watched in horror, something unimaginable was already racing toward Earth. 1 billion tons of superheated plasma, torn from the sun's surface, now hurtled through the void at 4 million miles per hour, 4 times faster than any coronal mass ejection ever recorded. This was no ordinary solar storm. The magnetic field lines were twisted like coiled springs, compressed and loaded with unprecedented energy. Under normal circumstances, such a journey would take 3 to 4 days. But the sun had cleared a path. The ejection from September 1st had swept the solar wind aside like a cosmic snowplow. Scientists today call this the perfect storm scenario. 2 ejections. The first clears the path, the second races through unimpeded space. 17 hours. That's all the time humanity had left before its first encounter with the sun's full fury. But in 1859, there were no satellites to detect it, no space weather forecasts, no warnings. The world slept, unaware of what was coming. Telegraph operators across America and Europe closed up their offices. Ships' captains checked their compasses one final time before sunset. Farmers gazed at normal, calm skies. Earth's magnetic field, invisible guardian that had protected life for billions of years, stood alone against what was coming, and it had no idea it was about to be overwhelmed. The plasma cloud was now halfway between the sun and Earth, crossing a distance that light itself takes 8 minutes to travel. But this mass of matter was doing it in less than a day. Inside the cloud, magnetic field lines tangled and reconnected, building up energy like a coiled rattlesnake. When these fields collided with Earth's magnetosphere, the release would be catastrophic. 17 hours to impact and counting. August 28, 1859. 13 days before the world would change. In observatories across Europe and America, astronomers turned their instruments skyward, unaware they were watching the prelude to catastrophe. Richard Carrington, a 33-year-old British astronomer, had dedicated his life to mapping the sun. Every clear day, he would project the solar disk onto a white screen in his private observatory in Red Hill, Surrey, meticulously recording every sunspot. On this particular morning, Carrington noticed something unusual. A cluster of sunspots, massive dark regions on the sun's surface, each one larger than Earth itself. They were growing, evolving, churning with an energy he'd never witnessed before. 8,000 miles away, in the Rocky Mountains of Colorado, fur trappers reported something that terrified the indigenous peoples. The northern lights had descended from their usual realm, painting the sky in brilliant crimson and green, far south of where they should ever appear. In Boston, the operators at the telegraph office noticed the needles on their instruments beginning to fluctuate. Erratic, unpredictable, small pulses of phantom electricity coursing through the wires with no apparent source. Telegraph Superintendent E.W. Culgan recorded in his log, unexplained variations in current, messages interrupted, operators report sensations of static discharge. He had no way of knowing these were just whispers before the storm. Across the Atlantic, in England's Kew Observatory, the magnetometers, instruments that measured Earth's magnetic field, began showing subtle disturbances. The needles swayed gently, as if responding to some distant tremor in the invisible forces that hold our world together. Scientists would later understand these were the opening notes of a cosmic symphony. The sun was brewing something unprecedented, a magnetic storm of such magnitude that it would make the August 28th aurora seem like nothing more than a gentle prelude. For the next 10 days, Richard Carrington would watch those sunspots grow larger, more complex, more volatile. He sketched them obsessively, sensing something momentous was approaching, but unable to imagine what was truly coming. September 1st was coming, and with it, a moment that would pierce the veil between the cosmic and the terrestrial. A moment when a mild-mannered astronomer would witness something no human had ever recorded, and the modern world would receive its first taste of the sun's terrible power. September 1st, 1859, 11:18 a.m. British astronomer Richard Carrington sits alone in his private observatory in Red Hill, Surrey, projecting the sun's image onto a white screen. For years, he's been meticulously mapping sunspots, but nothing has prepared him for what he's about to witness. Suddenly, two ribbons of blinding white light erupt from the sun's surface. Carrington leaps back from his equipment, shielding his eyes. He's witnessing something no human has ever recorded, a solar flare in real time. He frantically calls for witnesses, but within 5 minutes, the cosmic violence fades. Carrington rushes to his journal, his hand trembling as he writes. He doesn't yet know he's just witnessed the starting gun of the largest geomagnetic storm in recorded history. 17 hours later, September 2nd, midnight approaches. Telegraph operator Elias Peck sits in his Boston station, tapping out routine messages. The night is quiet, too quiet. Then at 12:45 a.m., the needle on his galvanometer begins twitching erratically. Within minutes, every telegraph line in North America goes haywire. Operators watch in horror as their equipment sparks and smokes. The electromagnetic pulse from Carrington's solar flare has arrived. But the true spectacle is unfolding overhead. From the Arctic to the Caribbean, the night sky transforms into a celestial theater of impossible colors. In Havana, Cuba, just 23 degrees from the equator, where auroras should be impossible, people pour into the streets. The sky burns crimson and green, pulsing like a living thing. Ship captains in the mid-Atlantic stumble from their cabins, convinced the sky is on fire. Some prepare lifeboats, certain the end of days has come. In telegraph offices, something even stranger begins. With their batteries disconnected and systems powered down, operators discover they can still send messages, powered entirely by the geomagnetic currents surging through the Earth itself. The storm's fury builds through the night, compass needles spin helplessly, birds fly in confused circles, the entire planet's magnetic field is under siege. And this is only the beginning. The geomagnetic storm will rage for 8 days, rewriting what humanity thought possible about the sun's power to reach across 93 million miles of space and touch our world. September 2nd, 1859. Dawn breaks over Boston. Telegraph operator Frederick Royce arrives at his station to find something impossible. Messages arriving on machines that have been disconnected from their batteries all night. In the American Telegraph magazine, he would later write, "I was awakened by the most extraordinary auroral display and immediately proceeded to test the working of the line. To my astonishment, I found that I could work it without the aid of battery power." Across the Atlantic in England, operators reported the same phenomenon. At the telegraph house in Norwich, operators disconnected all power sources, yet messages continued to flow. The aurora itself had become their battery. But the sky's gift was also its curse. In Washington, a telegraph operator watched in horror as sparks erupted from his apparatus, setting the paper tape ablaze. He beat out the flames with his bare hands. In Philadelphia, the surge was so powerful that one operator received an electric shock that threw him backward across the room. The invisible currents coursing through the wires had become weapons. Yet between these violent surges came moments of eerie beauty. Operators discovered they could converse across hundreds of miles using only the aurora's energy, ghost messages carried on celestial currents. In Pittsburgh, operators conducted an experiment. For 2 hours, they communicated with no batteries whatsoever, powered solely by the storm raging in the magnetosphere above. They were surfing waves of space weather. The messages themselves took on a strange quality, fragmentary, urgent, almost prophetic. Operators reported feeling as though they were intercepting transmissions from another realm, messages not entirely their own. One operator in Boston transcribed what came through. "The line is working beautifully, signals strong, I can hear you perfectly, the lights, my God, the lights." Then silence, then chaos. For 8 days, telegraph operators existed between two worlds, the physical network of wires beneath their fingers and the invisible electromagnetic ocean overhead that had taken control of their machines. September 1st, 1859. As night fell across the Western Hemisphere, something impossible began to unfold. The aurora borealis, typically confined to the polar regions, started its migration southward. In Havana, Cuba, sailors stumbled from their ships, pointing skyward in disbelief. The tropical night sky was on fire with crimson and green curtains of light, dancing where they had no right to be. Across the Caribbean islands, indigenous peoples and colonial settlers alike watched as their world transformed. The aurora stretched across the equatorial sky like blood-red rivers flowing through emerald clouds. In Panama, miners dropped their tools. In Jamaica, entire villages emptied into the streets. Many fell to their knees in prayer, convinced they were witnessing the end of days. One witness in the Caribbean wrote, "The entire vault of heaven appeared to be in a blaze. We could read a newspaper by the light as easily as by the full moon." But this celestial spectacle was not limited to the tropics. In Colombia, witnesses reported the aurora extending south of the equator itself, breaking every known law of geomagnetic behavior. In Rome, Pope Pius IX himself witnessed the display. The Vatican's astronomers frantically took notes, struggling to explain what their instruments showed. The Earth's magnetic field was in complete chaos. Chaos and wonder walked hand in hand. While some saw divine judgment, others witnessed beauty beyond comprehension. A painter in Paris later said he wept, knowing no canvas could ever capture what he saw that night. The auroral display pulsed and writhed like a living thing. Witnesses reported waves of color sweeping across the sky in rhythmic patterns, some describing it as the breath of the heavens itself. In the southern hemisphere, Australian gold miners in Queensland watched the southern lights intensify to unprecedented levels, matching their northern counterparts' fury across the planet. This was not just a light show. Ships' captains reported compasses spinning uselessly. In Boston Harbor, every compass pointed south. In Sydney, they pointed north. The Earth's magnetic poles had temporarily ceased to exist. The wonder came with a price. As the aurora reached its peak intensity, the chaos it represented became undeniable. This was nature's fury dressed in beauty's clothes. For 8 consecutive nights, the phenomenon continued. Each sunset brought anticipation and dread. What would the darkness reveal? What new impossibility would the night sky deliver? September 1st, 1859. While telegraph operators marveled at their ghostly communications, another crisis was unfolding on the world's oceans. Captain James Thornton of the merchant vessel Morning Star stood on deck, compass in hand, watching the needle spin like a possessed clock hand. His log would later read, "The compass has abandoned us to madness." For 8 consecutive days, Earth's magnetic field wreathed in agony. The invisible lines that had guided humanity for centuries twisted and reformed like serpents in the sky. Ships bound for Liverpool found themselves miles off course. The Pacific Mail steamer, relying on dead reckoning alone, nearly crashed into the Farallon Islands in thick fog. In London, the Admiralty received desperate reports from across the fleet. One captain wrote, "It is as if God himself has reached down and scattered the poles of the earth." Navigation masters at maritime academies were at a loss. Their instruments, their training, their entire understanding of geomagnetic navigation had become obsolete overnight. Sailors reported compass needles pointing south when they should point north. Others watched their needles dip vertically, as if pulled by some force beneath the ocean floor. On September 3rd, the British surveying ship HMS Challenger recorded compass variations of over 20 degrees in less than an hour. Their carefully plotted course became meaningless. Whaling ships in the Arctic, already navigating by stars and instinct, found even their backup methods failing as the aurora raged day and night, obscuring celestial navigation. The magnetic storm didn't just confuse compasses, it corrupted magnetic charts themselves. iron filings and demonstration models scattered into chaotic patterns that defied explanation. Harbor masters from Boston to Bombay reported ships arriving hours late, or worse, not at all. The ocean had become a lottery of chance, where skill meant nothing. For 8 days, the world held its breath. Would the magnetic field ever stabilize? Or had humanity witnessed the permanent breaking of nature's most reliable compass? Ships' captains made impossible decisions. Stay in port and lose fortunes in delayed cargo, or sail blind into waters where every heading could be fatally wrong. The nightmare navigation crisis revealed a terrifying truth: civilization's mastery of the seas hung by the invisible thread of Earth's magnetic field, and that thread could break. To understand what happened in September 1859, we must journey into the violent heart of our sun itself. The sun is not the peaceful golden orb we see in our skies. It is a roiling cauldron of nuclear fusion, where magnetic fields twist and contort like living serpents. On September 1st, 1859, astronomer Richard Carrington witnessed something no human had ever documented before. 2 brilliant spots of white light exploded on the sun's surface. What Carrington was watching was a coronal mass ejection of unprecedented scale. 1 billion tons of charged particles were hurled toward Earth at over 4 million miles per hour. This magnetic storm would reach us in just 17 hours. Normally, such a journey takes 3 to 4 days. This storm moved at nearly double the speed. We were about to be blindsided. When this magnetic tempest collided with Earth's magnetosphere, it compressed our planet's protective shield like a physical blow. The magnetosphere, which normally extends 40,000 miles into space, was crushed to just 4,000 miles above the surface. Electrical currents, measuring in the millions of amperes, were suddenly induced in the ground itself. The entire planet became a conductor. Telegraph wires became antennas, capturing these geomagnetically induced currents. The delicate instruments never stood a chance. But the auroras were the visible signature of billions of solar particles colliding with our atmosphere at incredible speeds. Each collision excited atmospheric gases, causing them to emit photons of light. Oxygen glowed red and green, nitrogen pulsed blue and purple. The storm was so powerful that these collisions occurred not just at the poles, but across the entire globe, down to latitudes where auroras had never been seen. For 8 days, the sun continued to erupt. Wave after wave of magnetic chaos battered our world, each surge writing a new chapter in atmospheric fury. What happened in 1859 was not an anomaly, it was a warning, a reminder that we live at the mercy of a star 93 million miles away. September 1859. The world stood at a peculiar threshold in human history. For the first time, civilization had wrapped itself in an invisible web of copper wire and electrical current. Just decades earlier, a solar storm of this magnitude would have been nothing more than a spectacular light show. Beautiful, harmless, a celestial wonder witnessed by those lucky enough to be awake. But by 1859, humanity had done something it had never done before. We had built a planetary nervous system, thousands of miles of metal wire stretching across continents, humming with electromagnetic potential. We had, unknowingly, constructed the perfect antenna for a solar apocalypse. The telegraph system wasn't just communication infrastructure. It was a continental-scale conductor, perfectly designed to capture and amplify the geomagnetic chaos about to rain down from space. Previous solar storms had occurred in a pre-industrial world. They left no mark, no record, no victims. But this storm would strike a civilization that had just become vulnerable. The telegraph operators of 1859 were pioneers, sitting at the controls of humanity's first truly global technology. They were also, without knowing it, sitting at ground zero. The timing was catastrophically perfect. Not too early, when the network was too small to matter. Not too late, when we might have understood the danger. But precisely at the moment of maximum vulnerability. No surge protectors, no circuit breakers, no understanding of space weather, just thousands of miles of exposed copper wire waiting to become a weapon against those who built it. And on the sun, 93 million miles away, something unprecedented was building. A magnetic eruption so powerful that it would turn our greatest technological achievement into our greatest vulnerability. 1859 was devastating, not because the storm was unique, but because for the first time in human history, we had given it something to destroy. We had built a civilization on lightning, and we were about to learn what happens when you cage electricity during the perfect storm. September 1st, 1859 was a warning shot across the bow of civilization. But in 1859, humanity's technological infrastructure was primitive. A few telegraph wires, some copper lines. Today, we've built a cathedral of vulnerability on a foundation of electromagnetic dependence. Imagine it's tomorrow morning. You wake to find your phone dead. Not the battery, the device itself, fried from within by a storm you cannot see, carried on solar winds at 1,000,000 miles per hour. Across the globe, as the sun rises on different time zones, the same realization dawns. GPS satellites have gone silent. The invisible constellation that guides every plane, every ship, every Uber driver to their destination, simply gone. Power transformers, the massive metal hearts pumping electricity through our cities, begin to fail. Not one or two. Thousands. Each one takes 12 to 18 months to replace. Each one costs millions, and we don't have spares. The National Academy of Sciences has run the numbers. The economic impact in the first year alone, $2 trillion. But that's just the beginning. The cascade effect is what truly terrifies the experts who lie awake at night thinking about this. Water treatment plants shut down. No electricity means no pumps. No pumps means no clean water flowing to 40 million Americans within the first 48 hours. The grocery stores empty in days as supply chains collapse. Hospitals switch to backup generators, but those have fuel for maybe 72 hours. Then the life support machines go quiet. Dialysis centers close their doors. Pharmacies can't refrigerate insulin. The vulnerable die first. They always do. The financial system experiences cardiac arrest. Banking networks offline. ATMs dead. Credit cards just plastic rectangles. The entire architecture of modern commerce reduced to whatever cash you happen to have in your wallet when the lights went out. Nuclear power plants scramble to shut down cooling systems that no longer respond. 48 reactors in the United States alone. Each one a potential catastrophe if the cooling fails. Fukushima, Chernobyl. Those names echo in the emergency response rooms. And the aurora, that beautiful harbinger of destruction, dances across skies where it has no right to be. Miami, Mexico City, Mumbai. People look up in wonder, filming on phones that will never upload those videos, as the world they knew quietly ends. The Department of Homeland Security estimates 18 months to restore partial grid functionality. 18 months of a civilization holding its breath, rationing, adapting, surviving, or not surviving. The mortality projections are classified. There's a reason for that. But here's what keeps the scientists up at night. We know it's coming. Not if, when. The sun operates on cycles. Solar maximum returns every 11 years, and every century or so it unleashes something like 1859. We're overdue. The Carrington Event was not a once-and-forever occurrence. It was a preview. In 2012, a solar storm of equal magnitude missed Earth by just 9 days in our orbit. 9 days. The thickness of a cosmic razor blade between normal life and civilizational collapse. September 1st, 1859. Richard Carrington stares up at the sun through his telescope, witnessing what no human had ever documented before. He doesn't know it yet, but he's watching the trigger being pulled on a cosmic gun aimed directly at Earth. Within 18 hours, that solar eruption slammed into our planet's magnetic field with the force of billions of atomic bombs. Telegraph operators watched in horror as their machines burst into flames. Sparks flew from metal keys. Paper caught fire. And then, something impossible happened. Even with their batteries disconnected, the messages kept flowing. The aurora's electromagnetic pulse was so powerful, it became the power source itself. Nature had hijacked human technology. People in Havana, Cuba, walked outside to read newspapers by the light of auroras that should never reach the tropics. Ship captains watched their compasses spin uselessly, pointing nowhere and everywhere at once. For 8 days, Earth's magnetic field convulsed like a wounded animal. Our planet's invisible shield, the very thing that makes life possible, had been breached. Today we live in a different world. a world wrapped in an invisible nervous system of satellites, power grids, and fiber optic cables, a world exponentially more vulnerable than Carrington could have ever imagined. In 2012, we dodged a bullet. A solar storm as powerful as the Carrington Event tore through Earth's orbit, missing us by just 9 days. 9 days. Had it hit, experts estimate $2 trillion in damage, a technological dark age. The question isn't if another Carrington Event will happen, it's when. Scientists estimate a 12% chance in the next decade. Those aren't comforting odds when civilization itself hangs in the balance. Imagine, no GPS, no internet, no power for months, maybe years. Transformers melted like candle wax, satellites fried in their orbits, 7 billion people suddenly thrust back into the 19th century, but without any of the infrastructure to survive there. We have warning systems now that Carrington never dreamed of. Satellites watching the sun's every move, computer models predicting storm trajectories. But warning isn't protection, it just means we get to watch the wave coming. Some nations are hardening their grids, installing surge protectors the size of buildings, creating backup systems, but it's expensive, politically difficult, and we're racing against a clock we cannot see. The Carrington Event wasn't a once-and-forever anomaly. Evidence from ice cores and tree rings shows similar storms struck in 774 AD and 993 AD. They happen. They will happen again. The sun doesn't care about our stock markets or our smartphones. So are we ready? The honest answer is no. Not even close. We've built a magnificent house of cards called modern civilization, and we're hoping the wind doesn't blow. That's not strategy, that's prayer. But knowing isn't powerlessness. Every day we don't face another Carrington Event is a day we can prepare, a day we can harden our defenses, a day we can build resilience into our fragile, beautiful, technological world. Richard Carrington witnessed the sun's rage with nothing but a telescope and his determination. We have so much more. The question is, will we use it? Or will we wait until the skies light up with auroras that were never meant to be seen and watch our world go dark? For 8 days in September 1859, humanity witnessed the raw, unbridled power of our star. The Carrington Event didn't just set telegraph machines ablaze, it ignited a revolution in how we understood our place in the cosmos. Richard Carrington, sketching sunspots in his private observatory, became the first human to witness a solar flare. In that moment, he saw something no scientist had dared to imagine. The sun was not constant. It was violent. It was alive. When those charged particles slammed into Earth's magnetic field 17 hours later, they painted the sky in colors that defied imagination. Miners in the Rocky Mountains woke at 1 a.m., convinced it was dawn. Ships' captains in the Caribbean watched green curtains dance across tropical skies where aurora had never been seen. Telegraph operators watched in horror and wonder as their machines burst into flames, yet continued to function. Messages crossed continents without batteries, powered by the sky itself. It was as if the Earth had become one giant electric circuit. Compasses spun wildly, pointing everywhere and nowhere. For mariners who had relied on magnetic north for centuries, it was a terrifying revelation. The invisible forces that guided civilization could be overwhelmed by something far more powerful. But from chaos came clarity. Scientists realized we don't live in isolation from the sun. We live inside it. Earth exists within the sun's atmosphere, its extended corona, forever bathed in a solar wind that shapes our magnetic shield. The Carrington Event gave birth to space weather science. It revealed that our star could reach across 93 million miles of void and touch us, alter us, threaten us. The sun was no longer just a source of light. It was an active force in human affairs. Today, we live in a world far more vulnerable than the telegraph operators of 1859. Our civilization runs on satellites, power grids, and digital networks, all exquisitely sensitive to the same forces that set those telegraph offices ablaze. Scientists estimate that a Carrington-level event today could cause $2 trillion in damage, 10 times worse than Hurricane Katrina, and leave half the planet without power for months, even years. The question is not if, but when. Yet there is hope in understanding. We now monitor the sun constantly, watching for the telltale signs that Carrington first sketched. We have early warning systems, protocols, hardened satellites. We are no longer blind to the storm. The 1859 storm taught us humility. We are not separate from the cosmos. We are participants in it. Every breath we take, every thought we think happens under the influence of a star that can, without warning, remind us of its power. Richard Carrington died in obscurity, his observations largely dismissed by his contemporaries. But his legacy lives on in every solar physicist, every space weather forecaster, every engineer who works to protect our fragile technological world from the fury of our nearest star. The storm of 1859 lasted 8 days, but its impact echoes across centuries. It changed not just our understanding of the sun, it changed our understanding of ourselves and our place in a universe far more dynamic, dangerous, and magnificent than we ever imagined. Thanks for watching. Don't forget to subscribe and check out other videos.